Welcome back. Here are the answers to the practice. I'm hoping you've already done the practice, and if you have, please check out the answers. If this is what you got, then all is good. Please just go back to the Nearpod and start working on the next topic. If these aren't the same answers that you got, then please stick around and we'll work on them together. Give you another half minute or so to check the answers out. Okay, we're going to take the answers away and we're going to start working on the practice. So do we have two perfect cubes here? Because if we don't, there's no point. Well, sure we do. Obviously, this is the cube on x, and this is the cube on 4. 4 times 4, 16, times another 4, 64. So we have our first factor, and we're going to have a trinomial factor. First factor is easy. Cube root of x to the third minus the cube root of 64. And then we're going to figure out what the first term is here, what the last term is, and what the middle term will be. So what do we multiply times x to make x to the third? That would have to be x to the second. Down at the right, what do we multiply times negative 4, and it comes out negative 64? Well, if we multiply times the negative and it stays negative, this has to be a positive 16. Negative 4 times positive 16 multiplies out to negative 64. And then for the middle term, we go back to the first factor, multiply these together, and change the sign. Well, these multiply out to negative 4x, but when we change the sign, it becomes a positive 4x. And that will be our factorization for the difference of these two cubes. Calculus has a lot of factorization, and they expect that you know these rules for the cubes. So here, obviously this is the cube on x, and I'm sure you know that 27 is the cube of 3. So we can rewrite the first factor really easily, cube root of x cubed plus the cube root of 27. And then what do we multiply times 3 to get x cubed? That'd have to be x squared. What do we take times a positive 3 to get a positive 27? So it ends up with a plus 9. And then we think, what do you multiply times x? We did that, sorry. Then we multiply these two together and take the opposite to get what goes in the middle. So 3 times x, 3x, take the opposite. There's the factorization. The next one's a little trickier. To be honest, if this had been negative a cubed plus 8, if that's the problem they'd given us, I would just use the commutative property and change it into 8 minus a cubed. And then we'd have the difference of two cubes and could go from there. But that wasn't what they gave us, so we can't do that. I know you learned in the last lesson how to take off a common factor. Pulling out the greatest common factor, and we do have a common factor here. It's negative 1. So if we factor -1 off the a cubed, factor -1 off the -8, now we've got 2 cubes, the sum of 2 cubes, and we can work with it. The -1 will still be part of the answer, but we can factor this. We'll have the short factor and the trinomial. So this would just be the cube root of a to the third plus the cube root of 8. And then to get this part, we're going to look at the a cubed plus 8 after we've taken out the -1. We're not going to go back to the original. We're going to use this. So to get from a to a cubed, this would have to be an a squared. To get from +2 to +8, you'd have to multiply by +4. And for the center term, we'll multiply the 2 times the a and change the sign. And we're done. If you felt like it, you could multiply the -1 here, make this -a minus 2. You would not multiply times this one. But in calculus, that's the fully factored form. Okay, so number 4. This isn't a perfect cube. Neither is this. But maybe this common factor deal is going to work again. Any common factors we could pull out of both of these terms? Well, they both have an x. Both have an x we could pull out. And both of the coefficients are even. So at the very least, we could pull out a 2. Maybe a 4, I don't know. I'm going to start with a 2. And just taking out the common factor. So if we take 2x out of this, we would have to have 125 here to come up with a 250. And we'd have to have x cubed in order to come out with x to the 4th. These two multiply out there. Now if we're pulling a 2x out of this, 2 out of 128 would be 64. And we wouldn't need any more x's. We already pulled out the only x there is. That, my friends, is a perfect cube. And we already know that 64 is a perfect cube. So we can go ahead and factor this. Bring down the 2x. And then we're going to have the 2 cube roots and the trinomial. So the cube root of 125x to the third, that would have to be 5x. Plus the cube root of 64, we already found out that is just 4. And then we work to figure out how we would multiply to get each of these parts. I'm going to do the first part. What do we take times 5x to make it come out 125x to the third? Well, we need 25. And we need an x squared. And then on the end, what do we take times 4? Positive 4 to get a positive 64, we'd have to have a positive 16. And in the middle, we would multiply these two together and then change the sign. So that would be negative 20x. And that would be the factorization. And it's time to move on to the next topic.